Welcome to our class. Okay, so we are going to be taking a look at the most important topic in mathematics. Okay, so the topic is trigonometry. Okay, so this is one of the most important topics. Okay, so this is an introductory video. Okay, so we are going to be looking at radians, degrees, their concepts and conversion. Okay, so that's what we are going to do. Okay, so our learning objectives of this lesson is to make sure by the end of this lesson you're going to be able to understand what is radians and degrees. Okay, so then we're going to convert between radians and degrees. Okay, then explain why radians are essential in higher mathematics. Okay, so these are our introduction. Okay, it is very introduction. Okay, so you have to make sure you subscribe to make sure you know many things about trigonometry, and you have to understand other things which are in trigonometry. Okay, this is just an introduction, so make sure you are in touch so that you don't miss what is very important. Okay, so let's take a look on what is degrees, what is radians. First, let's look at the key concepts of this trigonometry topic. Okay, so the first thing is you have to understand what are degrees. Okay, so degrees, they are units of measurement of angles. Okay, so we are going to see that degrees, they are units of measurement of angles. Okay, so this means that a circle, a right round, a circle is 360 degrees. Okay, so this is what we use every day. Okay, so let's see, these are just units. Okay, so you can know that a right angle is 90 degrees and a straight line is 180. I'm assuming you know all that. Okay, so now let's talk about radians. Okay, one radian is an angle which is made at the center. Okay, so let's say you have an arc like this. Okay, so it's an angle which is made at this center. Okay, when this radius is equal to this arc length. Okay, so when you're on an angle, this arc length, when this arc length is equal to the radius of this circle. Okay, this means that here we have 1 radian. Okay, so this is how radian are. Okay, so a circle consists of 2 pi radian. Okay, so this is an irrational number. Okay, so we're going to look at it as we know, as we're going, and we're going to understand it as we grow in this topic. Okay, so here we can understand that radian is an angle which is made at the center when the arc length is equal to the radius. Okay, so when you see that this arc length is equal to the radius, okay, this means that here we have a 1 radian angle. Okay, so radians, they are units of angles. Again, they are units of angles. Okay, but in this case, you can see that this a circle is 360 degrees, but a circle here is 2 pi degrees. Okay, so we can now say a half circle, a 180 degrees, 180, 180 degrees, 180 degrees is equals to pi radian. Okay, so we can now understand about it. Okay, so now let's see how do we convert this. Okay, so if you want to convert from degrees to radians, okay, all you have to do is you want to convert from degrees to radians. You just have to say pi over 180, pi over 180 times that angle you have. Let's assume it's theta. Okay, so you're going to be using theta a lot, so you have to pay attention here. So if you want to change from degrees to radians, you just have to say pi over 180 times theta. Okay, so if you want to change from radians to degrees, okay, so how do we do that? If you want to change from radians to degree, you just have to say 180 over pi times theta. Okay, this is the angle. In this case, it's in rad. Okay, in this case, it's in degrees. Okay, so we can see that this is our conversion. We've learned that what are degrees? They are units of angles, and the circle is 360 degrees. Then what are radians? Radians, they are units of angles again. But in this case, 1 radian is an angle which is made at the center when an arc length of a sector is equal to the radius. Okay, so this is our understanding, and you have seen that you can convert between degrees and radians using these two formulas. Okay, so you have to remember these two formulas. Now, let's take a look at an example. Let's say we have a work. We are going to work out these examples. Okay, these are just simple conversions. Okay, the first is just that convert 120 degrees to radians. Okay, so we have a formula. If you want to convert from degrees to radians, okay, what do we do? Okay, we want to convert from degrees to radians. We just have to say pi over 180 times the angle we are given in degrees. Okay, so this is our formula. Okay, here we see that you can just say, you just have to substitute 120 here, so it becomes pi over 180 times theta degrees, which is 120 in this case. Okay, so now we just have to cancel out this and see how to get. Okay, here we can see that 60 here 2, then 60 here 3. Okay, so this means that our answer becomes 2 pi over 3. Okay, so this will be our angle, which is 2 pi over 3 radians. Okay, so this is how we convert it as easy as that. Okay, now let's see here how to we want to convert this to degrees. Convert pi over 4 radians to degrees. Okay, so here if we are going from radians to degrees, we just have to flip here. So this means that the answer becomes 180 over pi times theta. Okay, our angle. Okay, theta, our angle in radians in this case. It has to be in radians in this case. Okay, so now we just have to say 180 over pi. Then we just have to substitute our angle here, which is pi over 4. Pi over 4. Okay, so now we can see that we can say here it's pi cancel out. Then 4 into 18, it's 4 remainder 2. 4 into 20 is 5. Okay, so this means that our angle is 45 degrees. Okay, so this is how we do it. I'm assuming that you have wondered why are we now using radians instead of degrees. We've been using degrees all along, and they are simple. You have wondered why are we now using radians. Okay, so let me show you why we use radians in higher mathematics. Okay, so the first reason is radians are simplified calculus operations. Okay, in derivation and the integration, these operations are simplified. Okay, derivatives like this one, which is the derivative of sin x is equal to cos x only when x is in radian. Okay, so this one was tested and it only holds when x is in radian. If it changes, it doesn't hold. Okay, so this is the other reason why we are now using this, to make sure that our calculus operations will be easier. Okay, the other thing is we just have to use trigonometry identities. Okay, these trigonometry identities, they are only neater. Okay, they are easier to use if they are in radians. Okay, and the other Taylor series. Okay, there is a series called Taylor. I'm assuming you know it or you will know it. Okay, so these ones are neater if you use in radians. Okay, then in circular motion and periodic functions. Okay, this one is common in physics and engineering. This one we use radians for natural measurement. Okay, so if you use radians for natural measurement in these ways, okay, you can easily operate with it. You can easily operate with the trigonometry of it, the Taylor series, and the derivatives of it. Okay, so this is the reason why we use radians. Okay, so now we have talked about degrees and radians. Okay, so next we are going to be looking at the other topic which is important in this trigonometry topic. Okay, so make sure you subscribe and you stay in touch so that we can go together and make sure we understand what is trigonometry and why to use it and where to use it, okay, and how we are going to use it. Okay, so thank you.